So here we are supposed to sketch a trigonometrical function, and let's say we've been given a function, and our function in this case is f of x is equal to 3 cos x plus 1. Now whenever they give you a trigonometrical function to sketch, normally they give them to you in pairs, so maybe sometimes they can give you g of x also is equal to sine 2x, like that. So what happens is this: if you are supposed to sketch two functions on one graph, the idea is that you are supposed to sketch them one by one, and don't try to do both of them at the same time with this particular method. Now with this method, what we are just simply going to do is we're going to use plotting. Plotting is the simplest way, and you can always avoid getting this particular question wrong by plotting. And for us to plot, we will use our calculator. Now for us to use our calculator, we need to make sure that first of all we reset the calculator. This is because sometimes our calculator can be set in a different mode. Usually the calculator is supposed to be in degree mode, not in radians mode or gradient mode. If you don't know which mode it is, the best idea before you do any trigonometry is to reset your calculator. Now once you've reset your calculator, you must know how to punch your function into the calculator. Now how do we punch the function into our calculator? So here we're saying punch function into calculator. Now the big question is, how do we punch our function into the calculator? Now there are very simple steps that you are going to follow. The first thing you are going to do is to press the mode button, and when you press the mode button, you get three options, and from the three options you must press the one that gives you the table. Now the table will then give you the function. Once you press the table, it will give you a function. Usually table comes out once you press the button 3 after mode. Now the function will then come out, and in this case it will have function, or it will have f of x is equal to, then you press your 3, then you press your cos on your calculator. Now to press the x, you need to first of all press the alpha button. Most cases have it as a maroon or pink button, and then you press x. The x is also in the same color as the alpha button, and then you easily just press your 1. Now I have an example of a calculator, and this time I normally use a sharp calculator, and this sharp calculator, it is very good, and as you can see, it's not quite clear at the top there, but I'm just going to show you how I punch that calculator. So the first thing you are going to see me pressing is the mode button there. When I press the mode button, I'm going to see different options. That's table at 3, and then I'm going to see function. Now function starts with 3, then cos, then you go to cos there. After you get to cos, then you press alpha button, which is green in this particular, or blue, and then you press the x button. Can you see where it is? And then there's plus, and then there's 1. Now once you've pressed that, you press the equal sign, and you now choose your starting point. The starting point depends on the graph, so here we're going to press minus 180, yes, because my graph is going to start from 180, and then from 180 my step, always to avoid any problems, is always going to be 30, and then it's going to take you to a table. So when you're using that calculator, that is how you press that one. Maybe we should go over it again. So here we go. Let's go back, and then we say function mode. When you see function, then we see 3, then we see the cos, then we see alpha, there we go, pressing alpha, and right there you can see I'm pressing alpha, and then x, and then from x I then go and press plus, then 1. Now I'm just going to say equals there. Can you see where it's just start? Now for the Casio calculator, here, this is where the Casio calculator will say start. You start from where the domain of the graph, which I'm going to show you, where they are asking you to start, and then you are, for the Casio calculator, because the Casio calculator runs out of memory, so you have to break up the domain into pieces, so that usually I would start from minus 180, and then I'll go to 0, then again to continue I start from 0, then go to maybe 180, then from 180 to 360, to avoid the calculator saying error because it's running out of memory. But for the sharp calculator, which I'm using right now, it will not have that problem. It will not run out of memory, so you are going to be safe with this calculator. So as you can see now, I'm going to press my star, my starting point, which was negative 180, and there is negative 180 right there. Pressing negative 180, and I'm going to press equal, and I'm going to put my step as 30. It's very important for you to understand why we put the step of 30, because the step of 30 is going to allow you to work with smaller gaps between the points. If you make the gaps too big, you might miss some points and you miss the shape of the graph. So the best thing is to use the smallest step, and the safest step to use is always going to be 30. Now once you've got that, you are going to press equal, and you will get this table. Once you get this table, you are now ready to plot. As you can see here, you are having your x values and your y values on the other side, and then once you are done, you can then scroll down. As you can see, I'm going to scroll down. Yes, as you can see, I can scroll down to see all the other values. And remember, you must know when to end, and sometimes the calculator will ask you to end this particular one at 270, so I'm going to go back to 270 right there. And then once I'm back at 270, I can now then continue with plotting these values. As you can see, there you go. So that is the plotting part of the graph, and now we can continue with looking at our function now. So normally what they do is they give you the function and they give you a graph to draw on, and in this particular case you'll be given the graph that you're going to be asked to draw on, and it will have the necessary axis. I'm just going to put some values there. Now remember what I said, they will give you a scale, and this scale, clearly if you look at the scale which is on this graph, it is using 90 as the difference between the two scales. In other words, the step on the graph is 90. But I'm not worried, because I know that on my calculator I was punching 30, and we said we must always use 30. So all you do is you divide this one into 3 equal parts. Each section you divide it into 3 equal parts. You don't have to be very accurate. You don't have to try and make them equal. It's just a rough sketch, remember, for you to be able to see the shape of the graph and where the graph intersects. Now from there, you are then going to now be required to plot. Remember, this is going to be maybe 2, then 4, then 2 there, so that it is negative 2 there. Sorry. So now you are being asked to sketch that graph. Now, to sketch that graph, remember this graph is starting from negative 180. Remember when we were passing our calculator? And if you are still having your calculator, you can now then try and plot with me and see whether you understand what is going on. So at negative 180, I am having negative 2. So negative 2 is somewhere here. Do you see that? So I'm pressing negative 2. And then the next one, obviously the next step is 30. It's negative 150. If you don't know it, as long as you have divided into 3, you know your steps is going to be 30. So the next step is going to be at minus 1,59. I don't have to be very accurate. I just go approximately to where it is. And then the next one is going to be at minus 0,5, somewhere there. and then the next one is going to be, I'm scrolling down my calculator, it's just going to be 1. So the next one for 90 is going to be 1. So my graph is keeping on, it's going up. As I scroll down, the next one is going to be 2,5. 2,5 is somewhere here. And as I scroll up again, the next one is 3,5. 3,5 is going to be somewhere there. And then the next one is just 4. So this graph is going to go somewhere up there. Now I'm going to now keep going as I'm plotting 3,5 for the next step. It's almost symmetrical. Then 2,5 for the next one. Yes. And then the next one is going to be just 1. There you go. And the next one is going to be minus 0,5 somewhere there. The next one is going to be 1, is going to be 2. This is going to be 2. Let me just check. 0,5 minus 1,59 minus 1,59, which is somewhere there. And then the next one is going to be 2. Yes, there. And the next one is going to be minus 1,59 minus 1,59, and that means it's now going up there. And the next one is going to be 2 is going to be here, minus 1,59 somewhere there. And then the next one is going to be at 0,5. 0,5 is somewhere there. As you can see, as I'm moving, I'm going up now, and then the last one is going to be at 1. So I can clearly see that if I try to follow the general trend of my graph, so I'm just going to draw the general trend of my graph. Remember, you are not going to try, you are going to try and remove the rough edges. So this graph is going to go like this, and you don't have to be picture perfect on passing through the spots. It has given you a guideline, and you now know that that is how the graph is going to come out. Now, very nicely, as you can see, before the points just look like that, and then I had to draw the graph so that you can see what is happening. So let's go back, start from this point. Remember, you just follow it. You know the general shape of a sine graph is going to be something like this, and you don't have to follow each point. Some points will be out, but you follow the general trend of the curve so that the turning points are seen visibly. The turning points must be seen visibly, and if you can see the turning points, and then you know that you are on the right track. So once you are done with that one, then you can go ahead and sketch the next graph. It is very important to put the points for the first graph and draw the first graph. Don't try to put the points for both the graphs and try to join them. Otherwise, you end up forgetting which points belong to which graph. And we don't have time to waste, so you draw one graph and then you draw the next one afterwards. That is one way of drawing the graph. The other way of drawing the graph is by looking at its elements. So I'm going to use the other method to draw the other graph which we were given. Let's go back and look at which graph we had. We had a graph sine 2x. Now, in this particular graph, we know that it's a sine curve. So if it's a sine curve, it has got an amplitude of 1. So the highest point it can go to is 1. The lowest point it can go to is -1. So I'm just going to show you that I'm highlighting. You're not supposed to do this. So this is the highest line that you can have for that graph, and this is the lowest line that you can have. It is rotating around 0. That is why if you go back, you will notice that it's just sine. There's nothing. There's no plus something there, so it's rotating around 0. Okay, and here if you look at this part here, the amplitude is 1, which means the highest it can go from 0 must be 1. Now, the next thing we want to look at is its period. Its period in this case is going to be 180, which means a full graph will span 180. So if a full graph is spanning 180, it means for it to go up, it will go up to 45, and then it will come down. So you just know the properties of the graph. So I'm using the period, and I know that from 0 to 180, I must have a full graph. So this graph must cross there. So let's try and draw that graph. So this graph, remember I said it is going to cross there, and then it is going to be a full graph, and sine starts from 0 going up. It's going to reach its maximum there halfway to 90, come down, and then go down, reach its maximum, come back up. So in other words, its maximum is there. So every 90 is going to have half a graph. So here it's going to come down. Do you see that? But here I'm not doing any plotting. I'm just using the properties of the graph. And it takes a very special skill to do this. You need to know your amplitude. You need to know your center of rotation. I would go with just using the one for plotting to avoid you having to think too much. You plot your points and you join them carefully, and you use a scale of 30. That helps. And once you've used the scale of 30, you can just draw the smooth curve. As you can see, I left some of the points out. I'll just show you some of the points which I left out. I left out some of the points as I was sketching. I left out this point, can you see? Because I didn't plot it properly. I also had put this point, but I didn't follow it. And this point is not exactly on the line. This one is not exactly on the line. And I know they don't have to be on the line. They're just giving you a general curve to show you where the graph, around the area where the graph is passing. And you draw a smooth curve so that you can get your full marks. So you'll get your marks for the turning point and the intercepts. So this is how you sketch a function. I hope that is going to help you, and you will try to follow the tutorial.